Okay, question 8 is probably one of the least well done questions in this whole test, so I would like to talk you through the points as they were marked, and hopefully it will make some sense to you. The question is about an aircraft that is landing on a runway, and the velocity has been given by the equation 50 plus 50e to the negative 0.5 t, and t runs from 0 to 4. That is crucial, especially in the later part of the question when this velocity will change. So the first part anyway is about to find the velocity when it lands. And when it lands, that's when t is equals to 0, because this is the velocity of this plane on the runway, that is after landing. So at the moment when it lands, this is when t is equals to 0. So we simply plug in t is equals to 0 into that equation, and that should be 100. That I think most of us got fine. The second part is when t is equals to 4. Again, we plug in t is equals to 4 into the equation, and that is 56.77 something. This is one of the biggest problems. There was 3 significant figures. A lot of people did lose that point for not writing that to 3 significant figures. So that's 56.8 meters per second. Now the next part of the question is simply write down an integral. It didn't say anything about calculate this, so simply write down the integral. And that integral is obviously the velocity with respect to time from t is equals to 0 to t is equals to 4, because it is the first 4 seconds after landing. So you get 1 mark for the correct function, and that could be perfectly okay if you just write it as v of t, and then 1 mark for the lower limit and 1 mark for the upper limit. Then part C is where you calculate that, and you do not need to be able to integrate that, although if you did, that would still give you the same value. But like this mark there suggests, it's a point that you simply get from plugging that into your GDC with the correct limits and get a value 286. Again, this is to 3 significant figures. Beware of that. Now the second part is where things got slightly offhand. After the first 4 seconds, this is after the first 4 seconds, the velocity changes. Now the aircraft is decelerating or slowing down at a constant rate until it comes to rest at time t is equals to 11. So the first part is to sketch the graph of this of the velocity against time for this aircraft for the first 11 seconds. So please note that in this case, the first 4 seconds, that graph is the exponential part. So if this were to continue, it would continue like that, approaching a limiting value. But at t is equals to 4, that point there, then the situation changes to a constant deceleration until it comes to rest. So from t is equals to 4 up to t is equals to 11, that is a constant deceleration, which means a straight line. So the graph changes from being exponential to a straight line all the way up to t is equals to 11. And therefore, the mark allocation for this part was you get a mark for the exponential part of the graph, a mark for the straight line part of the graph, a mark for labeling the axis correctly, a mark for a scale relatively correct, and that is both the x and the y, so marking the 50, marking the 100, and a mark for marking the point t is equals to 4, which is the point where that velocity changes.